Materials Studio 2026 introduces a range of new features designed to enhance the experience of materials modeling professionals. Materials Visualizer now supports modern Python scripting, providing you with a familiar and powerful alternative for building workflows. The help system has been expanded to cover the new API. Toggling between Perl and Python syntax is simply done, making code referencing and learning more accessible. You can also set the preferred default script language for the copy script function, streamlining the workflow setup. Python scripting extends across all aspects of model building and simulation control, allowing for automation in research tasks. In classical simulations, the integration of the minimum energy path task within Forcite enables direct measurement of energy barriers. Chemical reactions may now be studied using MACE machine-learned force fields, opening the door to accelerated chemical mechanism development. Also in this domain, a new protocol for fine-tuning of MACE machine-learned potentials can now be accessed. By providing new configurations to learn from, specialized force fields can be quickly built. Additionally, long-range corrections to the interactions can be applied with the D3 approach, leading to improved accuracy for a wider variety of material types. A new viscosity calculation tool is also available from the scripting menu, providing fast and convenient analysis of complex fluid systems such as liquid battery, electrolytes, and solvents. Both CASTEP and DMOL 3 now offer an automatic calculation restart feature. This option applies refined settings, simplifying the convergence process for new users and reducing manual intervention. Updated protocols for infrared, core level, and X-ray absorption spectra provide powerful new ways to interpret experimental characterization data with simulation. Performance enhancements and parameter coverage in CASTEP, DFTB+, and OneTEP accelerate time to solution for quantum simulations.